Today, we're going to go ahead with mineral groups because we've already talked about some of the properties of minerals like the luster, the hardness, the streak, the way the mineral breaks, how it transmits light. We've also talked about the criteria for making something a mineral. Examples include they have to be solid, naturally occurring, inorganic, internal crystalline structure, and they can be represented by a chemical formula. Today, we're going to talk about mineral groups. And the first mineral group that we're going to talk about will be silicates. The building blocks of minerals that are silicates is a silicon oxygen tetrahedron. Fancy words, but if you see this little diagram down here, tetra means 4. So it is 1 silicon surrounded by 4 oxygens. That's why we call it the silicon oxygen tetrahedron. And so if all silicates have as their building blocks the silicon oxygen tetrahedron, then 2 minerals that you would expect to find in 2 elements that you would expect to find in the formula of every silicate mineral would be silicon and oxygen. Now, the major groups of silicates would be feldspar is the major group. So the most abundant silicate minerals are the feldspars. And the second most abundant group is quartz. You recognize this as silicon here, 4 of these oxygens. So this is just, again, the silicon oxygen tetrahedron, which is the building block of all silicate minerals. Now, there are common silicate mineral groups, and I'm going to let you know what the groups are and give you some examples. Sometimes we have just a single tetrahedron in minerals. And an example of a silicate mineral that has a single tetrahedron is olivine. Now, olivine, the name of it and its color are closely related. We say olivine, and you can see that this shade of green is olive green. Even though we talked earlier about properties of minerals and we mentioned that color is the least reliable, but with olivine, that's not the case. Olivine, olive green. So if you get that color, you're okay. We also have single chains of silicate minerals. Each one of these is an example of the silicon oxygen tetrahedron that's in a single chain. And here's an example of a mineral, augite. Now, as you read within chapter 2 of your textbook, you may see the term pyroxene instead of augite. It's the same thing. It's a silicate mineral that is single chain tetrahedron. And we also have double chain. You see, this is one of the chains here, and then here's the other chain. So that's a double chain. Hornblende is an example of a silicate that is a double chain tetrahedron. And then we have sheets of tetrahedron. You can see a whole lot of these things, and they're in sheets. And examples would be muscovite mica and also biotite mica. See, the tetrahedrons are arranged in sheets, and these minerals are flat, sheet-like structures. And then we also have 3-dimensional networks. There are a whole lot of these, and they're 3-dimensional. And examples of minerals that show this, that have this property, would be quartz, which is the second most abundant silicate mineral. And if quartz is that way, the most abundant silicate mineral is also, and the most abundant silicate mineral you remember is feldspar. And here's an example of feldspar. Now, all minerals are not silicates. And so we take the other minerals that are not silicates, meaning that they do not have silicon and oxygen in their chemical makeup, or we could say they do not have the silicon oxygen tetrahedron. So we can group these into one big group and say that they are non-silicates. But the non-silicates are also divided into groups. We have carbonates, which is an example of one carbonate is calcite. And remember from a previous lecture, calcite is an example of a mineral that has double refraction. If you put calcite on a piece of paper and there are letters there, it would appear to be double. And it's also the mineral that will bubble carbon dioxide when you put either vinegar or dilute hydrochloric acid on it. We also have non-silicates that are halides, and an example of a halide is halite, which is referred to as common sodium chloride. All right. The formula for calcite is CaCO3. Any formula that I put on here for you, those are the formula. That's the formula that you would need to know. So right now you only need to know two: quartz, SiO2, and then calcite. All right, now this is halite, which is an example of a halide, and I keep going. Okay, this is halite, which is an example of a halide, and we commonly refer to halite as rock salt, or we can refer to it as table salt. And you can look at this and see that it has little cubes. That's the way the shapes would be. Okay, and this one is an oxide, and this oxide is hematite. And when you look at the picture of it, it kind of reminds you of dried blood. And you know, blood has hemoglobin in it. So this is hematite, and it's an oxide. All right, this one is galena, and it is an example of a non-silicate that is a sulfide. Gypsum, and remember gypsum, we learned, is the mineral number 2 on the Mohs scale of hardness. And gypsum happens to be an example of a sulfate. And this one is sulfur. And sulfur is a native element. And what we mean by that is it is not combined with any other element, because all the other ones we had to learn a formula like CaCO3 or PBS for lead sulfide, but sulfur we just write S. It's a native element. It is not combined with other elements. All right, now this is a quick review, and we're not going to go over that. What I'm going to do is to put all of these questions in a handout for you, and you will look at the questions, refer back to the 2 videos, and see if you can answer those questions. And when we have our first Zoom call, or when we have the conference call, if you have any questions at all about any of these, you let me know. And if you can't wait until then you can call me, because you have my telephone number. So call me if you have questions. So don't worry about trying to copy these. When you take a look at the video, I will put these on Wolfden in handouts for you. Have a good day.